This is going to be a video to start us off on our new unit, Unit 1, Topic 3, Exponentials and Logarithmic Expressions. We're going to start today with SLT 13, which is going to have us experimenting with some exponents. Everyone should be on page 1 of the new packet. Take a minute and read page 1, number 1, the situation, and fill in the table. All right, so the bacteria doubles every hour, so everyone should have filled in 8, 16, 32, and 64. Now number 2 says, write an equation P for the population of bacteria as a function of time and verify that it produces correct populations for T equals 1, 2, 3, and 4 hours. The first thing we want to do is remember our Algebra 1 exponentials formula. Y equals A times B to the X, where A is the initial population and B is the exponential growth or decay rate. All right, so here the initial value when time is 0 is 4, so P as a function of T will be 4, and it's doubling, so times 2 to the power of T. So now to verify that this actually works, let's do P of 1 is going to be 4 times 2 to the first. That's 8. Check. P of 2, 4 times 2 squared. 2 squared is 4. 4 times 4 is 16. Check. We'll just do one more. 4 times 2 cubed. 2 cubed is 8. 8 times 4 is 32. So it works. All right. They want to make another table. Specifically, they want to fill in the population at each half hour. Unfortunately, they forgot to make these measurements, so they decided to estimate the values. Travis makes the following claim. If the population doubles in a half an hour, then half that growth occurs in the first half hour and the other half occurs in the second half hour. For example, we can find the population by finding the averages. So let's fill in what we knew before. And I'm going to put those numbers in. 8, 16, 32. Okay, so by Travis's claim, they grew 4. So that means in the first half hour they got 2. And then in the second half an hour, like plus 2, plus 2. Now here we grew 8. So by Travis's claim, this should be plus 4 is 12, plus 4 is 16. So in the third hour it was 16, so this is gonna be plus 8 is, I can add, is gonna be 24. Plus 8 is 32, and this 32 is plus 16, so that's going to be 48, and then plus another, so there we go. So that's what Travis thinks happened. All right. So it's his comment on Travis's idea. Now, I want you to think about the way Travis did this. And do you think Travis's idea works? Just put down whatever you think for number 4. Then Miriam suggests they fill in the table this way. To make the estimates, I notice the population increases by the same factor each hour. So I think this property should hold over each half hour as well. So she's using the word factor, which implies we've got some multiplication going on. So let's put our numbers back in. So we've got 8, 16. So now let's think. She's saying from here to here was times 2. Every hour we were multiplying by 2. So how could we multiply like this, boom, boom, in 2 steps so that it was the same as multiplying by 2? Like, what could each of these little green arcs be so that it ends up to be the same as multiplying by 2. Like what could I multiply by twice and be the same as times 2? Well, hopefully what you said is that we would multiply by the square root of 2. Because think about it, if I did square root of 2 times square root of 2, that would be the same as multiplying by 2. Like if I did root 2, that would be the same as times 2. So I think we might need a calculator for this. So at this point, I want you to go ahead and take out your calculator. All right, so we're gonna start with 4. All right, so I started with 4. So I'm gonna do 4 times root 2. I got the root by doing second x squared. And I'm just gonna estimate, so I'm gonna go 5.7. Because obviously this is not really the number of bacteria, but I don't wanna round. And I'm also not gonna type 5.7 into my calculator. I'm gonna do times root 2 again, and I'm using the answer function. So now the calculator will take 5.656, multiply it by root 2, and look, I get 8. If I do 8 times root 2, I get 11.3. If I do that times root 2, I get 16. $32, 45.3, and then sure enough, I get my 64. Oh, whoops. Oh no, there we go. 64, okay. So that's what Miriam thinks. Now, they want us to make a graph. Now, I'm gonna be honest with you. See this graph? It's fun, and you can totally graph it if you want. I'm just gonna graph a little bit. So like we have 0, 4, and then at 1 hour we had 8, which is here. But you're gonna see really quickly, like trying to graph these, like the half hour. So here they would be 7, but then Miriam's would be 5 point, see mine don't even line up. 5.7. I'm not gonna graph. You are, however, welcome to graph if the mood strikes you. I'm gonna use algebra. So Miriam wants to now know if it would go every 20 minutes instead of every 30 minutes. So let's see here. I'm gonna go and fill in 4, we got the 8. This is 16. This is 32. So think to yourself, again, this is all times 2. If I wanted to break multiplying by 2 up into 3 steps, 1, 2, 3, what would I have to multiply each time that multiplying by this 3 times would be the same as multiplying by 2? Well, hopefully, we are multiplying by the third root of 2. So I'm gonna point this out on your calculator. If I wanna do 4 times the third root of 2, I'm gonna go to math, and I'm gonna pick number 4. So I get 5.0304. All right, now, if I don't want to have to keep typing this, I can do times and then math. And then I can just keep pressing enter, and it will keep repeating my last calculation. 8, 10.1. Oh, no! Here, I'll do the 8 times math. 2, 10.1, 12.7. There's the 16, 20.2, 25.4, and 32. All right. So, what number did we use for a multiplier in problem 5? We used the square root of 2. For problem 6, we used the cube root of 2. If I wanted to do 5.3 hours, 5.3 hours is, let's see, if I did P of T and I just use my equation, so P of 5/3, I could just do 4 times 2 raised to the 5/3. Think about it, like 1, 2, 3, 4, 5 multiplying by root 2, like raising it to the 3rd root of 2 5 times, just like our rational exponents would tell us. All right, so let's take a look at page 4. Oh, there's nothing there. Huh, how about that? So I guess that's it, guys. Video over. Excellent. Your homework tonight is page 5, numbers 12 to 20. I bet you could probably get that done right now. Good work.